Hello, this is Team 4, and we will be presenting on our proposed Edge solution, Speaker Matrix Pro, the device for presenters and public speakers. Speaker Matrix Pro is a wearable AIoT Edge device based on Raspberry Pi. Designed to be used during presentations or talks, it provides real-time and post-feedback on several aspects such as pace, clarity, and audience attention rate. These are the components and technologies used in the project, which will be further elaborated in the video.
Speaker Matrix Pro acts as a wearable device for presenters during presentations or talks. It analyzes audience facial landmarks and determines the level of engagement during a presentation or public speaking event. It provides the users various prompts, such as the estimated time frame remaining based on their script and the pace of the presenter. Users benefit from this device as it provides detailed analytics that offer insights into their performance. This includes a line graph depicting the pace of speech over time to identify fluctuations. Engagement levels throughout the presentations will be visualized, allowing the users to easily understand which portion of the presentation requires room for improvement. For the hardware component, the Raspberry Pi serves as the edge device. Connected to this device via USB port, the Logitech webcam acts as both the camera and microphone. In addition, a earpiece is connected to the device via the aux port, serving as a speaker. Moving on to the software components, the MQTT communication protocol is utilized, with EMQX serving as the platform for the MQTT broker. The AI modules comprises ONNX, OpenAI Whisper, OpenCV, and Scikit-learn. Furthermore, the web app server is set up using Nix.js and TypeScript, while Firebase is utilized for its authentication services and database.
The components in the solution includes the Raspberry Pi 3 that is connected to external devices like a Logi webcam, which has both camera and microphone capabilities, and also a earpiece to transmit sound to the user. There's also a user interface that allows the user to control the edge device, a database for persistent data storage, a cloud backend API server which does post-processing, and finally an MQTT broker that allows communication between the different components. In the user interface, the user can manage presentations in which the details will be stored in the Firebase cloud database. It also allows users to control the Raspberry Pi as well. It does so by publishing topics such as start and stop to MQTT broker, which the edge device will subscribe to, and then perform tasks accordingly. The Raspberry Pi will also publish to the initialized topic upon setting up to let the user know that the Raspberry Pi is ready to run and connected. The Raspberry Pi also performs several tasks in parallel, and they include running the text-to-speech model, automatic speech recognition, and capturing of frames. When the user ends the presentation through the user interface, the Raspberry Pi will do processing on those frames to get attention score of the audience in which the user is presenting to. The transcribed text attentive score per frame is then sent to the backend server through HTTP requests, which will then be stored in the Firebase cloud database. The user interface will subscribe to the real-time functionalities of the database to listen to any analytics that is being placed in the documents. Upon the analytics being stored in the database, the UI will also visualize the analytics for the user to see. The user interface also interacts with the backend server to retrieve, add, and update presentation details in the database.
Now, we will be demonstrating a use case of the Speaker Matrix Pro. Firstly, as you can visualize, the device comprises of three main components: the Raspberry Pi, camera, and the earpiece. The user is required to manually connect up all these peripherals. Next, the user is needed to connect to the web page on their personal device to create a new presentation by filling up the relevant details such as the transcript. After putting on the camera and earpiece, the user must connect the Pi to a power supply. This Pi will be connected to the server, which will be indicated on the web page. Lastly, the user will click on the Start button right before beginning his or her presentation. This essentially starts the processes on the Pi. During the presentation, the system will inform the user if he or she is speaking either too quickly or slowly. This prompt will be communicated through the earpiece. After the presentation is completed, the user can proceed to click on the End button. This will start the analytical process, which will be subsequently shown on the webpage in the form of graph and statistics.
For the conclusion of this project, we plan to enhance the speech analysis to provide users with more comprehensive understanding of their speaking habits and areas for improvement. For example, highlighting filler words in the user's presentation. Next, we will also be optimizing our model's implementation techniques to optimize the facial detection model, such as performing hyper-tuning, regularization, or pruning. Lastly, we will improve our design for scalability, where it can take in a bigger crowd and a longer presentation. Thank you for listening to our presentation.